Hello, this is Brett from SurvivalComms. Today we're going to talk about an HF antenna system that's extremely popular, the Chameleon MPAS. The MPAS, or Modular Portable Antenna System, is a multi-band, multi-configuration HF antenna system. They're rather expensive. They're around $600, and that's what I paid for mine. Over the course of the summer, we had a student in a class who used one of these antennas to great effect, and it was the first time I'd ever actually picked up any of the components and had any experience with it, and I was very impressed with his employment of the antenna system and also the construction of all the materials. So again, I went out and purchased one for myself. This video is longer than my usual content because there's an awful lot to cover. Nothing in this video was provided to me by a vendor or manufacturer, and one thing you will not see me do is regurgitate marketing when I review an item. I provide you with my testing protocol, observations, and opinions. The way this video will flow is I will set up the antenna in a vertical configuration using the hybrid micro, the spike, the mill whip extension, and the mill whip. Test this setup and then review the results. Then I'll do the same in a horizontal wire element configuration. The control antenna that we're going to use for comparison testing is my ZS6 BKW multi-band dipole. Then we will test and discuss all of the equipment and components provided with the MPAS 2.0. And it is my hope and belief that by the end of this video you'll be able to operate, maintain, and sustain this antenna system effectively. The strength of this antenna system is just how rapidly you can deploy it, and I'm going to show you that here in a second. We're going to set the antenna up in a vertical configuration, and the first item we're going to set up is this, which is the antenna or the Chameleon mill extension. And this is 16 gauge anodized aluminum tubing with machined 3/8 24 male and female at either end. Inside the bag here I have the Chameleon spike, which is stainless steel construction. I don't particularly like the Chameleon winder, so I use my own. This is just a Christmas tree winder, and I hold the feed line, the 50-foot of feed line with choke that it comes with. And then this, if you want to set it up in a wire antenna configuration, you can utilize this 70-foot of wire. Well, we're going to set this up as a vertical. The heart of the system, again, is the hybrid micro. So we'll go ahead and put our hybrid micro on our spike. We've already put together our mill whip extension. Now we'll go ahead and we'll put together our whip. The whip is basically Chameleon's take on the military AT-71, and it's very well constructed of brass, and it's spray painted with an olive drab finish. You would think it's shock corded, but it's not shock cord. What it is dummy cord, and there's a helical compression spring. Next, we're going to set up our counterpoise. Included with the antenna is one 25-foot counterpoise wires. Ground-mounted vertical antennas are incredibly lossy in relationship to ground losses, and the more conductors you can put on the ground, the more effective you can make a ground-mounted vertical antenna. So if you do elect to use the antenna in this configuration often, having additional ground conductors would behoove you. There's a 1024 thumb screw that's machined into the, or threaded into the base of the spike, and we're going to take our one included counterpoise and stick it on there. I don't use the winder. I prefer just to use the figure 8 style, and typically that makes for a very smooth employment. Now we're going to attach our feed line. There's 50 foot of feed line. It's included with the antenna kit, and there's an integrated choke, and we'll test the effectiveness of the choke later on. The 50 foot of feed line, you can take and elect to put the choke at the feed point, or you can elect to put it at the radio end. For using lower frequencies, it's a better idea to leave the choke at the radio end, because you're actually utilizing the feed line as an additional conductor. The shield of the cable acts as another counterpoise in a design such as this. Okay, we're doing our initial sweep with a bird Sighthawk, and the nice thing about using the Sighthawk is that we can save everything as a image file, and we'll discuss it later. And now we've made our second sweep, and we're covering above 17 meters through 10 meters, and you can see the results here. What you're seeing here is the sweep of the Chameleon MPAS in a vertical configuration with the mill whip extension and the mill whip with the one included counterpoise wire. And it's easy to see a sweep like this and become excited and think that, wow, this is amazing, look what it can do. Well, there's good news and bad news. The good news is the antenna performs as advertised, and I can use an automatic antenna tuner and tune all of these frequencies across the entire swept range without any problem whatsoever. The bad news is that this idyllic antenna sweep that you're looking at is due to losses. Number one, you have ground losses, and number two, you have feed line losses in the 50 foot of feed line, and also it's my estimation that there's a considerable amount of loss in this transformer, and we're going to put all of this to the test. So we added 3 additional radials to our antenna, and you can see the results here in the antenna sweep. Now you can see the changes, and the changes indicate that we have reduced the amount of ground losses, and our antenna is starting to behave more like what we would anticipate a ground-mounted shortened vertical to behave. To demonstrate the effectiveness of adding radials to a ground-mounted vertical, we've got the Chameleon MPAS outside with the one radial that's provided with the antenna connected. And we're going to make a transmission on the 20 meter band and record the result. Now we've attached 4 additional radials to the base of the MPAS in its vertical configuration, and in 20 meters we're making a transmission, and you can see the increase reflected here. This is our control antenna, the ZS6BKW, and our 2 stations having a QSO. Now let's go to the Chameleon MPAS in a vertical configuration. And you can see that the signal strength has dropped. And back to our control antenna. And now that's our control antenna. Repeating the experiment on 17 meters. This is our control antenna, and going to the Chameleon MPAS. And back to our control antenna.
I just put a jacket on.
We're back on the 40 meter band, and this is on our control antenna, and going to the Chameleon MPAS.
The microphone is a large diaphragm microphone, approximately equal to
and going
the
back
PR40,
to our control antenna.
with much better characteristics. The PR40 is just way overdone.
What's my signal strength on this particular antenna?
5/9.
Okay, you're 20/9 here. 20/9. Going to switch to antenna 2. antenna 2, on antenna 2, how copy?
You're in the weeds.
Copy. I see your signal has dropped to your 5757.
Yeah, your signal strength has greatly reduced.
How copy?
Loud and clear.
What's my signal strength on this particular antenna?
5 by 9.
Okay, you're 20/9 here. 20/9. Gonna switch to antenna 2.
Okay, standing by. You're in the weeds. Yeah, your signal strength has greatly reduced.
Read you loud and clear, man. You're doing 5 by 5 on the meter. I don't have any kind of amplification on, and you sound beautiful. No noise whatsoever.
Okay, cool. That's the ZS6 BKW antenna. I'm fixing to switch over to the other vertical. Stand by. Okay, how's that one sound? Definitely not doing as good on 40 meters with this antenna as with the ZS6 BKW. Okay, hang on. Okay, I'm back on the big antenna now.
Okay, yeah, I didn't copy you one bit on the vertical.
This data was collected using Whisper, the weak signal propagation reporter, and we did 4 bands and we did 8 hours per band. Now, the reason why we did 8 hours per band was because the data that was collected at first wasn't very impressive doing it for my typical half-hour test. Now, when you see this and you see all these contacts, you have to understand that not all those contacts represent a bidirectional talk path. Many of those stations could hear my station transmitting, but I couldn't hear them. And there's really very little way besides actually analyzing each station's data to establish that. And I could tell you from reviewing this data that 80% of the stations could hear my station, but I could not hear them utilizing this antenna in the vertical configuration. When we test the wire antenna deployment of this antenna system, I will also include the data that's gathered from the control antenna, and that way you can see a side-by-side comparison. Let's talk about what we learned about the vertical deployment and testing with the Chameleon MPAS 2.0. The first R is extremely quick to put it into play. I mean, the rapid deployment aspect of that entire system is very impressive. We were, 3 minutes with me talking the entire time, so that's pretty doggone impressive. The cons are that the low frequency performance of the antenna below the 30 meter band is not very good, and also the local performance of the antenna is not very good. Now, ground mounted verticals typically are very poor performers for local communications, and that's something to be taken into consideration. So what are some of the solutions we can employ to increase performance of this antenna in a vertical deployment? One is to add counterpoise conductors. It doesn't add a whole heck of a lot of weight, and that's a pretty good bang for your buck. And it's always good to have additional wire with you. You can elevate the feed point and elevate the counterpoises. That right there will increase performance. The problem with doing that is now you're complicating that deployment and you're losing the advantage of the rapid deployment. If you're going to do that, you might as well just deploy it as a wire antenna, which is going to outperform the vertical configuration. You can reduce the length of the feed line. I mean, you're not going to squeeze, you're just going to squeeze a few tenths of a dB out of that antenna system by reducing the feed line length, but anything you can do will help. Another option you may want to consider is removing the cap from your antenna and making sure you don't lose it. And just taking one of your counterpoise wires and have a test clip attached to the end of it and just clip that sucker on there and then run the thing as an inverted L. The only thing is, when you're adding wire to one of these antennas, you want to stay away from a half wavelength in length at any frequency you intend to operate on. There are multiple wire antenna configurations that you can set this system up with, and the manual that's included with this kit is actually really good. I mean, you could take that manual, even someone that doesn't really understand a whole heck of a lot about HF radio, and actually build one of their antennas and have relatively good success. What I'm going to do is I'm actually going to elevate the feed point in this particular one and just run the 73-foot wire out behind me, and we're going to do some testing with the antenna configured like that. So the first thing we're going to need to do is we're going to need to get something in the tree too. Well, now that we got our line up here, we're going to go ahead and make our connections. So go ahead and put your RF cable on. Again, you want your RF cable with the choke at this end in this particular configuration. Then go ahead and hook up your counterpoise wire. We're going to let the counterpoise wire droop. You can take this 25-foot of wire, pay it out now. Okay, take your shackle out of the top of your hybrid micro. And now you've got your feed point end of your antenna lead. Go ahead and thread it through your shackle. Like so, and tighten it up. And now take your snap link and snap it to your shackle, and you should have something like this. Now your support line, we're going to need to go ahead and tie this thing off. So I'm just going to use a bowline knot. Just like that. Now we're going to want to take enough antenna line off and take it away towards where we're going to set our antenna end up at. Now hoist your antenna. Rinse and repeat for your opposite end of your antenna. So you can see our hybrid micro in the tree, and you can see our antenna wire running this way. Here's a sweep of the MPAS with the wire elements attached and the feed point elevated as shown. Many are going to look at this and say that this really isn't that good of a sweep, that the first one that was ground mounted is much better. Well, what we've done by elevating the feed point is we've eliminated all the ground losses that hid the fact that the antenna was not performing that well as a ground mounted vertical. One thing to consider whenever you see something like this is that number one, the antenna is performing as advertised. And spoiler alert, it will match across the entire swept range of 1 to 30 megahertz with the use of an auto tuner without a problem whatsoever, including on 160 meters. However, at 160 meters and 80 meters, this antenna is going to be a dummy load. And again, starting at like the 40 meter band and up in frequency, the antenna is going to perform well, and we're going to go ahead and put that to the test. This is on 20 meters, and this is our control antenna and the MPAS.
Yeah, you're right.
And back to our control antenna. Here's our control antenna.
Very good. Thanks, Florida. I don't normally get to speak with Florida.
And the
For
MPAS.
some reason, to the south, I think you do pretty good.
That's
North,
the
east,
MPAS.
and west, but very seldom Florida.
And back to our control antenna.
But anyway, sounded very good, and there's some other gentlemen on
And back to the MPAS. This is WWV on 25 megahertz on the control antenna. And going to the MPAS. And back to the control antenna.
And learn the more
17 meters on the control antenna.
We get a different bunch of
And
people.
now going to the MPAS.
That are further away, and people that are very interested in the hobby.
And back to our control antenna.
Very smart. I ran into a guy here not long ago.
I fished shack from about 20 years ago, actually.
Alright, this is
25
15
years
meters
ago.
with our control antenna.
I thinned out,
and going to the
all
MPAS.
the old heavy iron there on the left-hand side. It was all,
And back to our
a bunch of
control
Barker
antenna.
Williams and Collins stuff over on the left. And this stuff.
Got you about a 5.7. 5.7 in the kilo. 1735.
QSL.
What was your state? Your state again?
I'm in Central Florida. Central Florida. Over.
338 Florida. Steppy Breeze from Delaware. 5.7, 5.5. I'll give you 5.7 here in Virginia.
QSL. This is the data collected using the weak signal propagation reporter, or whisper mode. And we have two antennas that we're looking at here. We have the Chameleon MPAS 2.0 set up in a horizontal configuration with wire elements, and also our control antenna, the ZS6 BKW. It's easy to see that the low frequency performance has definitely come up, and the performance across everything has come up by adding the wire elements and getting that feed point away from the ground. Now, the 40 meter performance on either one of these antennas is not that impressive, and that was due to me receiving broadcast station interference on the whisper frequency during the period of this test. You will note that the test duration also was only a half hour as compared to 8 hours for the vertical antenna, and this is due to the fact it was much easier to gather the data quickly with the MPAS 2.0 in a wire configuration than it was in a vertical configuration due to its increases in performance. All right, let's discuss our testing of the MPAS with a wire element configuration. Now, I did several different setups and only captured that one that you saw on camera. And one thing that was clear from testing the multiple configurations is the elevated feed outperforms the ground feed. If you set it up on the ground, yes, it's much quicker to do so, but it's just like setting up the vertical. You have a lot of ground losses involved, and you need to add those counterpoise conductors to that base in order to make the antenna effective. When you elevate the feed point, that's not a consideration. You just let that counterpoise wire droop. Well, let's talk about the pros of setting it up with wire elements. It's obvious that there is increased performance. You could see that from the testing, and that is due to the elevated feed point and also the use of much larger elements. And we also got much better local coverage out of having the antenna configured like that than over the vertical. The cons are, of course, it takes additional setup time to set it up, and also space. You have a much larger footprint with setting up the antenna with wire elements than you do just as a vertical. And you know, regardless of setting it up with that much of a footprint, the 80 meter through 160 meter performance is pretty doggone lackluster. So that's another consideration for this antenna. This antenna actually only really performs well, in my opinion, from 40 meters and up. So what can we do to increase performance? Well, if we insist on an elevated feed and we're setting up an elevated feed, in my opinion, the only way to increase performance in the lower frequencies would be to increase the radiator length. In the higher frequencies, the only way to squeeze any more performance is to discard the hybrid micro altogether and just go ahead and set the antenna system up as a resonant dipole. You're going to be using the same amount of real estate, the same level of complication, and there's no way this antenna system is going to outperform a resonant dipole. It's just not going to happen. Now, if we're ground feeding the antenna system, we can shorten the feed line up, and that's going to allow us to squeeze some more dB out. And again, just like the vertical configuration, we can add more ground conductors to reduce those ground losses. Well, I did say that we will test and discuss all the components provided with the MPAS 2.0, and so we shall. First thing we'll talk about is the bag and get that out of the way. The bag is a good overnight bag. It's not a good backpack, and it's not a good antenna bag. It's too big to be an antenna bag, and as far as a backpack goes, it has no suspension whatsoever. So my suggestion is not to use the bag and get something like this. This is the Rothco stealth rappelling bag, and it's actually a very good little tool bag that holds everything in there except for the mill whip extension. The next thing we're going to talk about is the winders. I don't particularly care for the winders. They're not bad. I wind everything in a figure 8, and the problem is this shock cord section here that they've got kind of gets in the way. You may like the winders. I'm just not crazy about it. This is how I roll when I wind my stuff. Like I said, this is just a $3 Christmas lights winder, extension cord winder. I chopped off some of the ends here, and I just wrapped the coax in a figure 8, the 73-foot radiator in a figure 8 pattern. I keep the hardware for the hybrid micro attached to a glow-in-the-dark piece of parachute cord and clipped to a small carabiner here. And then for the counterpoise wire, I just basically leave that bundled up like this. It's only 25 foot of wire. You can wrap it between your thumb and pinky to do it just like cordage, and that seems to work out just fine. I know some people are going to find this funny, but the piece of equipment that comes with this kit that I'm most impressed with, the most excited about, is the spike, believe it or not. You know, antenna spikes for ground-mounted antennas are usually pretty crappy. This one here is awesome. Like I said, it's all made of stainless steel. It's 2 different machine components. It's cross-drilled, and they have a split roll pin that runs through it. It's threaded for a 1024 screw, 3H24 here, and then the tip is actually ground down. It's not too sharp, so you don't have to worry about it knocking a hole in your bag or something like that, but it is sharp enough to where it penetrates the ground easily. Again, like I said, this thing is pretty doggone impressive in and of itself. Let's look at the inside of the hybrid micro. The hybrid micro is very well made. It's machined. It's constructed of aluminum and stainless steel and Delrin. And you can see the body here. We have the Delrin body that's machined. All the fasteners that are used to hold everything together are 832 machine screws of various lengths. We have an aluminum base here, and this is where your RF connector comes out. And then the inside here, you have an 832 screw that holds the ground side of the transformer. This stud is retained in place permanently by a blind install split roll pin, which is nice. The top cap is machined out of aluminum. And this is our hardware for our antenna end here, which is just a 3H24 bolt, a long nut, a lock washer, and a flat washer. Now, although the hybrid micro, the material selected, and the mechanical construction of it are quite remarkable, the electrical assembly aspects as shown here are not quite as remarkable and leave quite a bit to be desired. Circled in red on the left is our antenna connection. That's an 18 gauge wire coming out of the top of the 5-to-1 unun in a binocular configuration. And about 50% of the conductors were not even terminated in that ring terminal at the top there. So in the assembly there. Obviously, when the wire was stripped, someone just elected to crimp that terminal on there, and it's the wrong size ring terminal as well. That's not for an 18 gauge wire. That's more of like for a 14 or 12 gauge wire. On the right hand side, that is the connection that ties to the chassis of the RF connector through the aluminum housing. And that is a blue ring terminal, which again is the wrong size terminal. And again, it's just a standard automotive grade type of ring terminal that they've selected to terminate this wire with. And these are both very important connections to this device. However, the device still performed to specifications with these connections. I've made repairs of all of these connections. Okay, this is the kind of testing I like to perform. I've disassembled the hybrid micro, and here is the binocular core 5-to-1 unun out of the hybrid micro, and then I've taken an FT140-43 toroid, and I've made a 5-to-1 unun in a conventional fashion. Now, of course, the one out of the Chameleon looks really great on an antenna analyzer and has that nice almost flat, matches everything type of profile, whereas this right here is not nearly this generous under an open, short, and load condition. This graphic is of the hybrid micro under conditions of open, short, and load, and the load is 250 ohms, and with a 5-to-1 transformer, that's exactly what you would want to see. What we don't want to see is under conditions of open and short, that we're really not seeing those profound changes, which we'll see in a more conventional 5-to-1 transformer here in a minute. This indicates that there is loss in this device. This next graphic is our unun that we wound on an FT140-43, and this is more what we would anticipate seeing under open, short, and load. Under load, 250 ohms, everything is just as we would anticipate, but under open and short conditions, we have an infinite SWR, which is more what we'd expect. Now, this device here is going to exhibit less loss. Now, you may say to yourself, you know, what's the big deal with a little bit of loss? Look at the convenience we're gaining for just accepting a little bit of loss. Well, let's say there's 3 dB of loss across this transformer right here. That means if I'm squirting 100 watts of RF into here, I'm only getting 50 watts out. And that's with only 3 dB of loss. And what happens to that power? That power just doesn't disappear. That power becomes heat. And that battery power we're using to generate 100 watts at our transmitter is still using the same amount of current. And all we're doing is heating this device up. So if you look at it through that lens, we have a vested interest in mitigating loss. Now, one way we can measure loss in a transformer is just how hot the doggone thing gets. Let's perform a little experiment. This is our transformer out of our hybrid micro. It's attached to my transmitter on this end here, which is tuned to a frequency of 14 megahertz. Our transmitter is set for 50 watts of RF power out in radio teletype mode. Our dummy load is a 50 watt dummy load, and it's terminated to the antenna terminal and to the ground. We've used our antenna tuner unit, and it will deliver full power to this load, and we've already tested that. What we're going to do is we're going to see just how hot this transformer gets in service. So we're going to go ahead and use our infrared and you can see that we're sitting about 68.9, 69 degrees right now. Alright, we're complete. Let's see how hot this thing got. Ooh, a little warm, huh? Transformer here and see how hot it gets. Current temperature is 66.2. Now our test. We're ready to check our results of our test. And the temperature is just about where we were before. Well, that was interesting, and that pretty much reinforced our position that this transformer is quite lossy. So what we can do now is we can actually measure the insertion loss of this particular device. Now, buying another hybrid micro is kind of out of the question, considering they're around $200. So what I did was I just built my own transformer here that's just like this, and the open, short, and load shows you that they're identical in performance characteristics. And that it's going to slide right over our ferrites just like that, just like a glove. And congratulations, you've wound your 5-to-1 unun transformer. So the way we accomplish this is very easy. I talked about it in my video on checking balun transformers before. All you do is take your transformers, take the secondary sides and tie them together, and then hook the primary side or the low impedance side to our 50 ohm test equipment and measure the loss across both devices, and then take 50% of that loss, and that is the loss that's in one individual device. And the device we'll sweep with is just one of these nano VNAs. And like paternity court, the results are in. Let's see what we found out. Here's our sweep using the nano VNA across the hybrid micro, 5-to-1 binocular core unun, and the 5-to-1 binocular core unun that I built. And again, these are both back to back, and we can see that there is loss across these two devices, and it's an average of 3 dB over the entire range. You can see we're sweeping from 1 to 30 megahertz, and you can see our marker locations. And you know, the average in this circumstance is around 3 dB of loss across that, and that's across both devices. So each device would incur an insertion loss of 1.5 dB. And here is our sweep of the 5-to-1 unun that I built on the FT140-43 core. And the overall average loss across the device is 0.37 dB. So across one device, we're looking at an average loss of less than 0.2 of a dB. So what does all this mean, and why does it matter? If you look at this image, this is the insertion into the MPAS system in a vertical configuration of my unun wound on an FT140-43 toroid. You can see at low frequencies that the ability to match the impedance effectively with a shortened vertical is tenuous at best, and it will require quite a bit of tuner intervention. By selecting a more lossy transformer, the antenna is presenting a more pleasing looking load to the transmitter at the expense of increased loss in both transmit and receive performance across the entire range of the antenna, regardless of the selected elements, and we saw this in testing against our control antenna. The user of this system needs to understand that the convenience of this system is a best case 70% efficiency, and when we couple that with the observed feed line loss, we're looking at a 59.8% efficiency using this system. But you know, this isn't unique to this particular system. It is a consequence of compromised antennas. Here is a Chameleon mill whip next to a military surplus AT271. You can see them laid out here. The Chameleon whip, however, is entirely made of brass and weighs 1.5 ounces more. The Chameleon whip is just slightly shorter as well. I had made mention of the suspension arrangement for the antenna not using shock cord, that it actually uses a section of dummy cord tied into a helical compression spring that runs into this hollow recess in the base tube. It's important to remember when you're collapsing one of these antennas that you start at the tip and collapse down to the base. Don't be scared to employ the Chameleon mill whip or the AT271, whatever you choose, with just a spike mount. Just fab up yourself a piece of scrap aluminum like I've done, take a 3H24 bolt, and then just take a CB 3H24 mount and thread your whip into it and cut yourself some quarter wavelength radials, one for 10 meters, one for 12 meters, and one for 6 meters, and you're good to go. 3 of these elements extended brings us close to resonance in the 6 meter band. Having the antenna fully extended gives us resonance in the 12 meter band, and when you just have one element folded down, you're close to resonance in the 10 meter band. Again, the more radials you have, the more effective the antenna will be. This is the mill extension 2.0. It's aluminum tubing. It's 16 gauge tubing that fits very well together. Anybody that's ever worked with this kind of stuff knows that, you know, you can get aluminum tubing that fits together, but it's often very loose. This locks together very tightly. It uses shock cord, which is very nice. Keep it all tied together. But you can see the kind of fit that you're getting out of this here. And there's very little side-to-side movement in it, so it's very well made. You have aluminum inserts at either end that are machined, and looks like they're epoxied in, and then they cross-drilled it with a split roll pin, and it's threaded with a female end of 3/8 24 and a male end at the other end of 3/8 24. So again, this is a very, very well made piece of gear. The cable kit provided with the Chameleon MPAS 2.0 is 50 feet of RG58 with an integrated 5-sleeve choke. The coax connectors are crimp style connectors. The tail is covered in glue-lined heat shrink. The body of the connector is brass. It's nickel plated, has a gold plated center pin that's been soldered, and a Delrin insulator. The cable is produced by ABR Industries, which is an American company. Average loss of the 50-foot coax cable assembly provided is just under 9/10 of a dB. The performance of the common mode choke in the coax assembly is greater than 20 dB of attenuation within the amateur bands, as shown here. The antenna wire provided with the MPAS is of good quality. It's a Teflon jacket. It's a 16 gauge 10 copper conductor. Alongside of that is an aramid fiber or Kevlar fiber. Well, if you've made it this far to this video, thank you very much for your attention. Now, I'd made mention of the quality of the manual before, and it's obvious they put a lot of time into it, and a lot of the same material is cross-platform across their manuals, which is fine. You know, a lot of the theory information and stuff like that. And of course, the setup stuff is very well written, and excellent job on that. I wanted to make mention of that. And, you know, you could take this manual, which will fit in this bag, by the way, put this thing in a compartment, and if you needed to hand this whole bag to somebody and say, hey, I need you to set this up, even if they're a non-radio person, they're going to be able to execute that task because of the thoroughness of the manual, along with just how simple this system is. And that's a strength of this system. The strength of this system is it's flexible and simple to deploy. It's not the best performer in the world, and we'll talk about that in a minute. The components are well designed. They're made of quality materials. If you had to fix this thing in the field, you could do it. The only thing physically that I found wrong with it, and I've been through this system from stem to stern, was the wiring faux pas in the hybrid micro, and then I addressed that. And even with that wiring problem, the system performed just fine. It performed just like the specification said it would. Now, the performance-wise of this system, you know, it's pretty much on par with other large footprint, field expedient, your field deployable HF antenna systems. It is not as good as a resonant dipole or a multi-band balanced wire feed antenna like a doublet or something of that nature. And you shouldn't expect it to be, because that's not what it's intended for. This system is best for a radio cache for a group or an organization due to its expense. As an individual, I don't think it's a very good man-portable solution. It's probably not the best for backpacking because it's just too doggone heavy and too doggone large. So now we come to the point to where we rate this system, and we need to assign it some kind of a value. Due to the expense of this antenna system of $600, and I anticipated there being somewhat better performance for that kind of price. Perhaps if I would have bought it with the hybrid mini instead of the hybrid micro, which is a larger antenna matching unit, it might have performed a little bit better. But due to those factors, I'm going to give this Chameleon MPAS 2.0 a rating of 7 out of 10 stars. So I'd love to hear about your comments in the comments section, and I hope this helps. This is Brett from SurvivalComms. Till next time.